All right. Good afternoon.
Teacher.
All right.
Afternoon.
By the way, have you received
Good
the
afternoon, sir.
previous exercises in chemistry? I think I just sent it to your email. Okay.
The the
Maybe.
answers
Yeah. The no the result.
I
Anyway,
did not.
you can just check it
Okay,
later.
she did that.
Okay. Just check your result later
Is it through the mail, teacher?
through email. Yes.
Oh yeah, I already got it.
Okay. And then to those who haven't seen the
Sure, I did
result,
not receive
you
any.
can only yeah, you can check them
The email,
later.
Jeff.
Yeah, there's none.
Okay, I don't know them.
All right, so we're now going to proceed with our next lesson. So we are done with uh, interpreting a chemical reaction and balancing chemical equations. So this time, I'm gonna introduce the different types of chemical reactions. Now, basically, there are like approximately 20 types of chemical reactions, not yet including those chemical reactions that exist in organic chemistry and even in dealing with organic compounds. Uh, but uh, and also some of the reactions involving acids and bases. Okay, so most probably I will just be giving you first the basic chemical reactions, but those 20 chemical reactions are summarized into 4 general types of chemical reaction, and that's what we are about to discuss. Okay, so let's go to the shared screen. All right, so we have general types of chemical reactions. So let us enumerate them, and I will be giving some examples that shows each of the general type. Okay, so the first one is what we call direct combination. Direct combination reaction is also known as synthesis. So it's from the word synthesize. So we used to synthesize something in order to create new stuff. Okay. Now, in direct combination, it is easily described when we deal with this pattern of the reaction. So let me show you the pattern. So the pattern of direct combination goes this way. So you have substance A that reacts with substance B, and then after the reaction, it will become, so it will become substance AB. All right, so what have you noticed in this pattern? You have simple substances, A and B. Now, these two simple substances, they will combine. Okay, so you synthesize them by combining them, and you will form a new substance. That new substance is the combination of the reactants that are considered simple substances. Okay, so this is the pattern that makes it a direct combination reaction. Now let me give you an example of this. So let's say, for example, okay, let's say we have barium which will react to nitrogen gas. Okay. Now, what will be the result when barium reacts with nitrogen gas? All right. So I want you to type your predicted product in our line group. Okay. So look at the pattern. You combine them. What will be the result? Okay. Type it in the. Okay. We have an answer from Charson. Charson answered Ba3N2 or barium nitride. This is correct. Okay, so we'll be giving point for Charson. Okay, yes, the output or the product will be a barium nitride or Ba3N2. Okay. Do I need to elaborate where we got the numbers 3 and 2, or everything is clear? Okay, just recall the crisscross method that we've been doing before. Okay, so it's just the same thing. All right. Okay, another example. Let's say we are given um, Na plus O2. Okay, what will be the result when, and okay, we have an answer at once. All right, let's see. Okay, wait, I'll just fix this first. Okay, so we have answers from, who's the first one? Jaya. According to Jaya, it forms Na2O or sodium oxide. This is correct. Okay, so let's give point for Jaya. All right, yes. So we have, it will be sodium oxide. Okay, or Na2O. All right, so that's how direct combination reaction works. Okay, so is there any question regarding this type of chemical reaction? Shall we proceed now to the next?
Yes, proceed.
Okay, so let's proceed to the second one, which is, okay, so the second one is called decomposition reaction, or this is also known as um, analysis. Okay, so what is this decomposition reaction or analysis? So let me show you the pattern of how this reaction works. So in here, we have the substance AB, and then this substance AB will break into much simpler substances, such as A and B. So the pattern is AB yields A plus B. And what have you noticed with the composition reaction? Or is there anything that you've noticed compared to the first one?
They separate.
The opposite with the
They break up.
synthesis.
All right, exactly.
Chemically,
So decomposition reaction is the reverse process of a direct combination. So in here, you have the complex compound or substance. You will break it into simpler substances. Unlike in direct combination, you have the simple substances which you combine to form a much complex substance. Okay, and let's have an example for decomposition reaction. So let's say we are given, for example, let's say we are given NH3 or ammonia, and then, wait, so wait, what's going on? All right. Okay, so what will happen to ammonia when it decomposes? Okay, please type your answer in our line group. Okay, we have an answer at once from, who's this? Stefano said N plus H2, and then Javier said N plus H3. Okay, we have a correct answer from Jaya. Okay, so it's N2 plus H2. Okay, Charleston's answer is more specific, though Jaya's answer is still considered. Okay, so the answers are nitrogen gas, or N2, and oxygen, okay, or O2. All right, so we just break the compound ammonia into simpler form, which are nitrogen gas and oxygen gas. Okay, so anyway, the composition reaction is just the reverse of the recombination. So I think I don't need to elaborate it much. So we can now proceed
teacher,
to
what
the,
oxygen?
sorry, hydrogen. Okay, I'm so sorry. Thank you. This is hydrogen. Why did I? All right. So this is hydrogen. Okay. Any question? Okay. No question. All right. So let's proceed now to the third chemical reaction. Okay. So the third one is, okay, number 3, we have Single replacement. Okay, single replacement reaction. Now, well, we don't have equivalent term for this, so we just call it single replacement reaction. Okay, so how does a single replacement reaction work? All right, there are two patterns that we are to consider when dealing with single replacement. Okay, so the first, it depends on the condition. Okay, so the first pattern is, if A is a metal. Okay, so that's the first condition, that A must be a metal. Okay, now if A is a metal, this will be the pattern. So you have the free element A, which when reacts with the compound BC, it will yield, so this will yield the compound AC plus the free element B. Okay, so this will be the pattern if the condition is A is a metal. All right, and the second condition is this. So the second condition is if A is a halogen. So what will be the pattern if A this time is not a metal but a halogen? Okay, so this is how the reaction works. So you have the substance or the free element A, which reacts to the compound BC, and it will yield, so that yields the substance or the compound BA plus free element C. All right, now take a look at single replacement reaction. So as you can see, uh, there must be a free element and there must be a compound. So that free element will be replacing a certain atom in the compound. And once it replaces that particular atom there, it will create new substances. Okay, so that's what's going on with single replacement. So it's replacing another atom from the compound. That's why, as the name suggests, single replacement. Okay, so there is some sort of replacing another atom. Okay, now when we are dealing with single replacement, we don't just follow this pattern at once. Okay, when we deal with single replacement, because before you do a single replacement reaction, you should inspect first the metal or the halogen in the list of the activity series for metals and halogens. So let me introduce to you the activity series for metals and halogens. All right, so let's copy this there. All right. So we have this series of metals and halogens. We call this we call this the activity series of metals and halogens. Okay, what is this all about? All right, now I have here the list of metals. Okay, so in the list of metals that we have here, so the one with the highest reactivity or the most reactive is lithium. And then after lithium, it's followed by potassium, then barium, calcium, sodium, magnesium, aluminum, manganese, zinc, chromium, iron, cadmium, cobalt, then followed by nickel, tin, lead. Hydrogen is not a metal, but it will play a role when we deal with single replacement reaction that involves acid, steam, and water. Okay, so it will play important role there. Okay, that's why it's included here. And then followed by antimony, bismuth, copper, mercury, silver, platinum, and the one with which has which is least reactive is gold. So the most reactive is lithium. The least reactive is gold. All right. So that's four metals. And then for halogens, we have the following. So we have fluorine, then followed by chlorine, bromine, and iodine. Now the new halogens we will not consider yet because their properties are not yet known. Okay, so we will just focus on these four as our halogens. All right, so let's try to have an example, okay, and how we use this activity series. By the way, like what I mentioned a while ago, the list of activity series is arranged from the one with which is most reactive, and then the activity series is decreasing until reaching this. So from the highest reactivity to the lowest reactivity. So that's how it is arranged. Same as with halogens. So let us have an example for this. Okay, so like for instance, okay, let's say we have, for example, okay, so for example, okay, let's try this one. All right, let's say we are given uh, barium that reacts with sodium nitride. Now, can you tell me what will be the product when barium reacts with sodium nitride? All right, Mini answered barium nitride plus sodium. All right, barium nitride plus sodium, but let's check first her symbols, huh? Okay, Ba3N2 plus Ba3N2 plus Na. Okay, this is correct. Okay, so we have a point for Mini. All right. So let's write the answer here. So we have barium that will replace sodium to become Ba3N2, and then plus sodium will be the new free element. Okay. All right. So this will be the products. Okay. So this is correct. Another example. Let's say we are given Ba plus Li3N. Okay, what will be the products when barium reacts with, okay, so we have an answer from Jaya. Okay, let's see. Uh, his answer is Ba3N2 plus Li. Okay, do you have other answers aside from Jaya's answer? Then let's compare. Is there any more suggested answer? So his answer is Ba3N2 plus Li or lithium. All right, so Javier answered Li2N plus, all right, Stefano answered Ba3N2 plus Li3. Okay, another. I need more answers. Jeffrey said Ba2N2 plus Li. Another Li3N plus B. Okay, we have a correct answer from Javier. Okay, so the answer is Li3N plus Ba, the same as the original, the reactants. Why the answer is just the same? Or you can just write here NR. When we say NR, what does it mean?
No reaction.
No reaction, yes. So if no reaction, the result is just the same, Ba plus Li3N. Why no reaction in this case?
Because lithium has a higher activity.
Very good. Okay, that's correct. Now, if we go back to the first example, we have here barium, and this is barium. And then we compare barium to sodium. By the way, barium is a metal, so we will be looking at the reactivity series for metal. So barium and sodium, notice that based on the arrangement, barium is more reactive than sodium. Thus, barium can able to replace sodium from the compound sodium nitrite. Okay, that's why it becomes barium nitride plus sodium. But the second example is a different story. Why? Because in here, this is barium and it is supposed to replace lithium. But it just so happened that lithium is more reactive than barium. So if barium is less reactive than lithium, is there a chance for barium to replace lithium for the reaction to happen?
No.
No, okay. There's no chance for barium to replace lithium because it is less reactive than lithium. So that's the first thing that you should do. Inspect the reactivity series of metals or halogens before you decide for the possible products that will be produced in the reaction. Okay, so the checking on the reactivity series for metals and halogens is important when you are dealing with single replacement reaction. All right, is that understood, guys? Is that clear?
Yes,
Clear,
teacher.
teacher.
Okay.
Sure.
Clear, teacher.
So in this case, if the metal given is less reactive than the one it has to replace, then just put NR or no reaction. Let us have our third example. All right, the third example, let's say, for instance, we have Cl2 plus, um, let's say we have AlBr3. Okay, for example, AlBr3. All right, so what will be the products if this is the, okay, we have an answer from Jaya. Okay, according to Jaya, I'll just fix this. So according to Jaya, let's check in the line. AlCl3 plus Br. All right, do you have other answer? Okay, you can still suggest for more answers. Okay, AlCl2 plus Br. Okay, another. Wait. From Thierry, another from Baleron. Another. Give me another answer. BrCl plus Al according to Thierry. Jeffrey says AlCl3 plus Br. Okay, we got the correct answer from Jeffrey. Yes, this is correct. So it will be AlCl3 plus Br2. Okay. Yes. Jaya's answer is almost there, but he missed to make bromine into diatomic element. Okay, remember when we discussed this when you were in SME 1, we have 7 diatomic elements. Do you still remember the 7 diatomic elements? What are those? Okay, so we have hydrogen, helium, hydrogen, oxygen, what else? Nitrogen, fluorine, bromine, iodine, and fluorine. So those are the 7 diatomic elements. So when we do a single replacement reaction here, so you have aluminum and chlorine will replace bromine. So it will be AlCl and then 3 plus, okay, since Br has been replaced, Br becomes a free element. And since it's one of the members of the 7 diatomic free elements, you will put 2. Okay, is that clear?
Teacher, can you repeat that again?
Which part?
The diatomic thing.
The 7 diatomic elements. Okay, let's enumerate the 7 diatomic elements. So we have the 7 diatomic free elements. So they are, okay, so we have hydrogen, oxygen, nitrogen, fluorine, bromine, chlorine, and iodine. Oh, wait, I missed 2. Okay, so these are the 7 diatomic free elements. Okay, I'll just fix them. Okay, so you should memorize them, huh? I will not provide them when we do your tests or other activities. Huh? You should remember them. Okay. All right. So any question regarding the single replacement reaction before we proceed to the last one? Is there any question? No question?
Think not.
Okay, let's proceed now to the last chemical reaction. So number 4 is, anyway, this is a lot easier than that number 3. Okay, number 4 is called double displacement reaction, okay, or also known as metathesis. All right, so double displacement reaction or metathesis involves the following. Okay, so in single replacement, one element, one compound. This time, there are two compounds that will react together. Okay, so the compounds AB, which will react to the compound CD, and what will be the result? So when they react, okay, it will become, all right, so A will join D, and then followed by C, which will join B. So this is the pattern. AB plus CD yields AD plus CB. Okay, for you to easily remember, okay, it's just, it only goes like this. So A and D is in here. Okay, so they are the one to combine, okay, to form a compound. And the second is C, which will combine with B. Okay. So this is our, for you to easily remember. Okay. All right. Like for example, let's say for example, all right. Let's say we have let's say H3N plus BaOH2. So what is this? Hydrogen nitride plus barium hydroxide. Okay. So please type the result. What will be the, okay, Javier said HBA plus N. Okay, can you suggest another? All right, let's see from Mini, H2O plus Ba3N2. Okay, we have a correct answer from Mini. All right. So Mini got it correctly. All right. Let's analyze, huh? Okay, like what we said, A will combine D. Okay, so one atom of hydrogen and plus OH, it becomes what? It becomes H2O or water. Okay, plus, all right, Ba will combine with N, so it becomes barium nitride. How do we write the symbol for barium nitride? So it's Ba3N2. Okay, I will not elaborate this because we've been studying this before when we are dealing with nomenclatures of compounds. Okay, so just apply crisscross method if the compound is ionic. Okay, so this is the result. Or you can also say barium nitride plus water. You can also, you can swap them. It doesn't matter. Okay. Do you have any question regarding double displacement reaction? So it's easier for double displacement. Just follow this. Okay, and you will be guided on how to predict the possible products. Okay, so any question before we end this Zoom meeting? Okay.
Teacher will send the notes, right?
Okay, I will give you.
Okay,
All right.
thank you, teacher.
Okay, so if
Sure.
no more question, let's just call it a day. So goodbye,
Okay, teacher.
class.
Teacher,
Goodbye,
teacher,
teacher.
I want to ask.
Oh, somebody wants to. Okay, yes, Jaya.
Last time for the activity that teacher gave,
Mhm.
the number 1 N2O delta yields N2 plus O2, isn't it? 212.
Which one? The balancing.
Yeah.
Okay, I will check. You send the number item to the line group, and then I will check
Okay.
the
Sure.
form. Okay,
Sure.
yes, Javier.
I haven't received my email. Is it possible that I wrote the wrong email?
It is sent to the email you type in the
Important.
form.
Yeah, I didn't receive any. I think I typed the wrong email.
So most probably
Important you reach.
you put wrong email in your.
Most probably.
Okay, I will just, you will receive it again from the Google Classroom. Okay, so but
Sorry,
you
teacher?
you will receive again the result coming from the Google Classroom.
Okay, so I'll just wait for it.
But that will be a few days from now, not today.
Okay, it's okay. Thank you, teacher.
Okay. All right. So no more questions. Okay. So it's already time. So goodbye, class.
Thank you, teacher.
Goodbye. And
Bye.
thank you,
Thank
teacher.
you.
Thank you,
Hello,
teacher.
teacher.
Okay.
Thank you, teacher.